Good evening and welcome to tonight's webinar on Classpad.net. We will be taking a look at 3D shapes for area and volume. For the sake of webinar quality, we would like to keep everyone muted and all videos turned off. If you have a question, you can type it in the chat panel and one of our moderators will respond back or ask the presenter to respond to the entire group. We are also on Facebook Live, so for those of you just joining us there, welcome as well. And let's go on to the next slide, please. My name is Amy Chow, and I am the Training and Product Manager for Casio's Education Division. I've been here for the last 10 years. My current responsibilities are working with schools, districts, and conferences to set up trainings, as well as working with our development team on calculator updates and improvements. And presenting for us tonight is Dr. Karen Greenhouse, and I'll let her introduce herself.
Hello, I am Karen Greenhouse, and I am a math educator, is how I usually describe myself. Done a lot of things, as you can see in my little blurb there. But currently, I am an adjunct professor at Drexel University. I teach in their online master's program. And so I do a lot of remote teaching because everything I do is online. So I have some tips and things that I'm going to share throughout the webinar about that. And I'm also an independent consultant, so I work with teachers in different schools, school districts all over the country, and for the last 6 years I've been working with Casio. So part of that work has been with Classpad.net, and so I'm going to exit out of this and go into, hopefully, Classpad.net. And I know I recognize a lot of names on the webinar. I'm trying to share a paper with you right now, so I am going to be working in a couple activities with Classpad.net on 3D, but this is really going to be more of a how-to, and so I'm hoping for some questions and suggestions from you because honestly, I've been playing around with the 3D and there's some things I figured out and some things I haven't, so I'm going to be showing you some things that I've done. So this is Classpad.net, free online math software. You don't have to have an account, you can just start exploring, but creating an account is something I highly recommend because the paper that I just shared with you has several links to the activities that I'm doing. And if you want to keep them and save them forever, you need an account to do that. And so creating an account's really easy. You just click this button. I'm not going to do it just to save time, but click the button, sign up, and there's your account. And I'm going to show you the difference between having an account and not having an account in just a minute. I did want to briefly talk about something. When you go to, I'm going to show you logging in. When you go to log in or create an account, it hopefully comes up. Oh, it's not doing it. It asks you for your, if you want to sign up with Google, whatever. Just know that if you're using a school account, sometimes it won't let you sign in because of the firewall. So if that happens, just use I use a personal email account instead of my school associated just because of that. So just keep that in mind if you are trying to do it with your school email, that it might block you because of that. But I'm going to get into some 3D. So what I want to do, I'm going to kind of split this into several parts. I'm going to show you some already ready to use and how I kind of incorporated 3D or kind of faked the 3D using Classpad.net. Classpad.net does not have a 3D tool. If any of you are familiar with GeoGebra, it actually has 3D tools. We don't have that, but we have some ways that you can actually make 3D and play with 3D and really create some amazing 3D visualizations, and that's what we're going to focus on today. So this is just an activity that sort of helps students introduce what is even a 3D object, like what does that create, and kind of the underlying geometric constructions under it. And I don't know if you guys have ever seen that. Quick show of hands, how many of you have ever watched the Disney Donald Duck in Math Magic Land? Quick show of hands or something. Somewhere in the chat. Okay, so I got it's old. It's from, I think it's from the 1950s. But I used to always show this to my students, and one of the things I loved at the end, I think it's near the end, it takes a cone and it slices it off, and then it takes that slice, which is parabolic, and spins it, and that makes another shape. So it's showing you that these simple geometric shapes, 2D shapes, can make the 3D shapes. It was fascinating. So that's what this activity sort of is about. And if you have the handout that I just sent you, this would be the first one in the sheet. And all you have to do is click it and you can open it up and you're going to be in the same activity I am. And what I wanted to show you is this is basically saying this is a right triangle. This is a red right triangle. This dotted line represents the long leg of the right triangle, and it is now currently the axis of rotation. So this shape's going to rotate around it. What three-dimensional solid does this make? And I have used the trace features that are part of, I'm in a geometry sticky here. So this is geometry sticky. I know that down here at the bottom shows all my geometry tools. And so the directions are, take this green point right here and rotate it. So I'm going to do that real quick, and you'll see that I have the trace feature on, and I'm tracing both that point and the hypotenuse. And so what does this 3D, and again, remember, this is just a simulation, what is this 3D shape? So hopefully, let's see if anyone can identify it. What does a right triangle that's rotated around its long leg make? What 3D shape does it make? A cone, right? So this is a cone. So this is how students are, they're like, oh, a cone is just a rotation of triangles around a circle or a conic. So I'm gonna, and I hit the backward key right there to get rid of the trace and bring it back. Now, my trace, I'm gonna show you how the trace happens. I was tracing the green point, so notice how I'm selecting it, and the hypotenuse. And I'm going to go over here to my geometry tools, and you'll see that trace is on. I'm going to turn it off for just a second, just so you can see the difference. If it's not on, then rotating it doesn't create that nice visual that I want. But I turned it off for a reason, because now I want to change this rotation to be the short leg of the right triangle. So now I'm making it be the short leg. Here's the long leg. So now we have a rotation around a short leg of the right triangle. And so I'm going to turn the trace back on. So trace is pretty easy. Whatever you want to trace, you simply select it. And over here, you'll see that trace is always an option. And so I click it and it just puts a check mark next to it. Now that trace is on, I'm going to do the same thing, and let's go the opposite direction. So does this, whoops, I got to go a little slower. Is this still a cone? Well, it's a little hard to see, so I maybe could have changed this black dot, and you'll see in the directions lets me change the, oh, I still have my trace on, sorry about that. It lets me change the orientation a little bit. So these are just, it's really just a 2D simulation is what I'm doing to try to get you to see the 3D. And what I wanted to show you is the underlying constructs that I did, that I created to make this, quote, simulation. And if you go to, I've hidden things, so I'm going to make them visible just so that you can see them. That's what I did. I actually used the ellipse to make my circle or my conic, and then I used the center to make my right triangle and stuff. So I had underlying constructs that were helping me do this. And we're going to be working on those throughout the rest of this presentation so you can see them. So I'm just going to hide those again because let's hide those again. All right, so let me go down. I'm going to show you another one. So here is one that is a rectangle. And I tell the students it's a rectangle, and I want them to do the same thing. I want them to take this point and rotate it. And so what 3D solid does that create? Anyone? Real quick. So if I were working with students, let's say I'm working remotely with students distance, this is a visualization. I am doing a demonstration with them, and I'm asking them questions, and I'm asking them then in the chat panel, or however or maybe they're on voice in my Zoom meeting, have them explain to me what they think it is, and then tell me why they think it's that. Well, this is a cylinder. Why do you think that? Well, it looks like it has two circular bases, and this is a geometric hide show button that I created. And when I click it, there are the bases. So now I can see the underlying. Here's my rectangle going from the, one side is from the center to the outside of this circle or ellipse is what I really use. But now as I move around, I can see that I'm going on those two bases. And so what do we know about a cylinder? Well, it's made up of two circular bases and a rectangle is how I created the sides of that cylinder. So this is just an introduction of how some 3D solids are basically constructed, if we think about it that way. So this is just a fun thing. And again, I just used underlying, I made an ellipse, and then I used a translation to make an exact copy of it up here. So I'm going to be going through all this, but that was just an intro to how I am simulating some 3D using just basic shapes, rectangles, ellipse, and then some tracing features. The next thing I want to go into is a problem that I actually have adapted from Illustrative Math, just to show you another way. And I'm going to show you the underlying things after I kind of walk through this activity. So this is the second activity in the handout if you wanted to play along. But basically, this is a problem in the Illustrative Math. If you've ever been to Achieve the Core, this is a task that Illustrative Math has that matches the 7th grade geometry standards, where they have to describe a 2-dimensional figure from a that's a slice from a 3-dimensional. So they're told, this is the problem, they're given that this is A, B, C, D, E, F, G, H is a cube, and they're going to be using the cube the whole time, and they have to slice it in different ways and describe the slice. So basically, this is a problem that assesses their understanding of properties, right? So it's giving them an example of, say, if you cut this first one right here, this example to the right is cutting, it's joining the midpoints of all of side A, C, B, D, E, G, and F, H. So the midpoints have been connected, and this slice right here is a square. And so if I click on it, I'm looking at the dark square. How do I know that's a square? Well, what do we know? We know that this shape is a cube, which is a 3-dimensional object where all the sides are congruent. And if I take the midpoint of each of these and connect all the way across, this side is congruent to all the sides, and this side is congruent. So you're basically applying a bunch of properties, and you want students to explain that. So this is the assessment that they have to do from this object. I want to talk about how I created this. This object right here, I created, and we're going to going through this, by using the ability to turn on isometric grids in geometry. So I've turned them off, but I'm going to turn them back on so you can see how I created this. And then we're going to spend a little time going through creations in just a minute. So here's my geometry sticky. I'm going to go back to it. And you'll notice that there are 3 different types of grids, and they're automatically defaulted to be off, because most of the time in geometry, you tend to not want a grid unless you're working, like, say, in coordinates. But if I want to make a very specific 3D object, I like to use this grid right here, which is the isometric grid, not isomorphic. And then there's also a dot grid. So I'm going to turn this back on. So I've selected it, and I want to turn on the grid. So I have to do these 2 things right here. I have to select the kind of grid I want and turn on the grid. Notice I could also turn on axes and labels. And then I'm going to go down here. There's some options right here. So once a grid is on, you can choose to snap the points, meaning they're going to, if you move them, they will move nicely to a nice coordinate, or fix the points. I like fixed when I'm creating the shapes because I want them to be exactly on those intersections. So I've selected what I want. I'm just going to turn it back on so you can see how I created this shape. This shape was actually created with the Polygon tool, and I had it fixed to, well, it's kind of off right now, but I basically, quote, drew it, but I drew it with those constraints on it. It's fixed and went to a grid, and so I knew that I was making exactly the square or congruent sides because it was on the isometric grid. And then what I did is I selected all of my creations and locked them. So one thing that you can do in Classpad is if you select something, and I'm just going to select it now, and go to this, you'll notice that it says lock. You can lock points so that they can't be moved by students. So once I created the shape, because I knew I wanted them to just add things to the shape but not create anymore, I locked it so they couldn't change it. So this is sort of some of the things to keep in mind when you're creating things that you want students to work on. You can lock things, you can hide things, you can snap the points so that they always work to a nice whole number, or if you're on a coordinate grid, those types of things. So that's what was underlying this. So I'm going to go back and turn these things off because I don't want them on right now. And there's my nice shape again. So this one is again created. I turned off the grid before I sent it out to anybody. But if I turn the grid back on, you'll see that, well, I obviously moved it, but you'll see that it's on a grid. Maybe I didn't use that grid. I think I did. Oh, no, I guess I must have used the dot grid, not the isometric grid. So I use the dot grid because you can see they're on perfect dots. So that's what the fix did for me. It made sure that they were sitting right on those exact points. And then I did lock them, if I'm not mistaken. Let me check. You can always check by selecting and going over to that the little menu options on the right, and you'll see that it says they're locked. So I did lock them. And what does lock mean? So let me try and move it. I can't move it. It's impossible to move because I don't want the students to change the shape that I created. Because remember, this is technically a drawing, but if I draw it on the grid, it's exactly what I want using the property. It is a cube, but I don't want them to change it because if they change it, it's no longer a cube. So that's why the locking feature is really nice. So this one, this is just a continuation of this activity. Here's this same cube. We've taken the colors out to make this a little better to see. And so they're supposed to use the Polygon tool. So I'm just going to show you what they're going to do. I'm going to ask you guys to try to identify the shape that is constructed, the slice. We're slicing this 3D object, and we're making, and there, I need you to describe the shape that's created, and not just describe it, but tell me why you know. So I'm going to do what it says here. It says, take the Polygon tool and construct a slice of this cube that connects AC to edge EG. So I'm going to take my Polygon tool. So this is the geometric tools down here. Here's my Polygon tool. And I'm going to do what it says. It said connect AC. So we're going to start with A. We're going to go to C. And then I have to connect it down to E and G and then close it back here. So there is my slice. So this is real nice because I can see my slice in my 3D simulation. And maybe let me take the grid off again. So everybody look at that slice and tell me, what is that slice? What shape? How would you describe that shape? And if you give me an answer, I would like to know why. So Ish is telling me it's a rectangle. Okay, but how do you know that? And this is where these types of problems are not just about being able to identify the shape, but it's really about understanding your properties of the shape. Because this is a cube. What do we know about a cube? It's made up of square sides. So it's just saying the top sides are congruent. So this side, well, we know all the sides are congruent. So this side, AC, is congruent to EG. So they're congruent and opposite. Do we know that CG, so this diagonal side right here, do we know that it's congruent to its opposite side? Oh, and Robin is saying it's parallel. And yes, they are parallel because they are right angles here. So there's lots of reasons. So this is a great problem, very simple. And because we were able to simulate a 3D object, we can actually work with this problem. Students can actually work with this problem that is often very difficult in a 2D environment if they're just doing it with paper and pencil. So it's nice to be able to do that. And then there's one more where they're going to do the same thing. So you'll see that this activity has several parts. So let's just really quickly, this one is telling you, again, use your Polygon tool, but this time we want you to connect different things. So now I'm going to connect, let's see, the vertices C to B. So right there, I've created a diagonal to G and another diagonal to C. So what kind of, obviously I have a what? Looks like a triangle to me. What kind, is it a special kind of equilateral? It's equilateral, and I kind of hinted at that as I was doing it, because this is the diagonal of a square that's the same as this square. They're all congruent, and another diagonal. So if all the diagonals are from congruent squares, then congruent parts of congruent figures are congruent. So that is all equilateral. So these are the kind of problems that are really nice, and you can do them really well in Classpad by first constructing them in your different types of grids, so a dot grid or an isometric grid. And let's just do the last one just to challenge you. And then I'm going to go into how do you actually use these grids and do some constructions with you for those of you who are interested. So the last one is make a slice. And so you'll notice that this one, I constructed the midpoints of 2 of the sides. And so what do we already know about this? The sides are congruent so that these midpoints are splitting each segment into 2 congruent parts, and all those parts are congruent. We already kind of know that. These are properties that we're working with. And it says, now let's see if you can connect vertex A to, make sure I'm doing this right. All right, so this one's a little harder. And in the illustrative problem, when you actually look at their solution, they say this is the hardest one for students to do. But what kind of triangle would this be? Let's give and it is isosceles. So it's not equilateral because of this section right here is not, you know, a side of one of the diagonals or anything. But we do know that these 2 sides are congruent because they both connected A to the midpoint of 2 congruent sides. So all of these properties come into play. So again, this is just an example of a way that you can construct. You're technically drawing, you're not using a tool or anything to construct 3D objects so that you can do simulations and problems like this, visualizations. So the next thing I wanted to get into is how do you construct and how do you use these grids? So we're going to do a couple different things. We're going to get some advice from, I've been playing around with this, just trying to figure some things out myself. So for those of you not familiar with Classpad, this is what the page looks like before you put anything on it. And you can pretty much do whatever you want. So if I click anywhere on the screen, and it doesn't matter where I click, wherever I click, this menu option comes up. And these are all the things I can do. I'm signed into my account. If you look up here to the right, you see this cloud save. That's how I know I'm in my account, because if you're not in your account, and I'm going to go over to this one, notice there's no cloud save here. It's not saving anything because it doesn't know where to save it. You need an account. So that's another reason to sign up for an account, because you can save everything that you do. So I'm in my account, and so I'm going to use, here's all the things I could do. I could do some calculations, some graphing, some geometry, data, sequence, finance, write some text. But I'm just going to pull up the geometry sticky and just kind of talk about, first of all, some things that you can do to construct 3D. And I'm going to ask for some advice later on, but I'm going to show you some things that I've been playing around with, which I think are pretty cool. So first thing, the 3 dots. That's where, right now, this is a geometry default. There's no grid, there's nothing. And if I start doing anything on here, I could just start drawing. This is the, oh, my triangle's a little wibbly wobbly. I could just start drawing. This is our draw tool, and it just lets you draw. If I did a circle, hopefully, oh, that's a bad circle. Oh no, it worked out well. So you could just start drawing and notice there's no grid. Well, I don't want to do that. I actually want to turn on the grid, and I actually want to get rid of what I just did. These arrows down here undo the last things that you did, so I got rid of them. I don't like the auto labeling. So when I'm working in some things, I tend to turn that off. I don't want the labels to automatically. So 3 dots in this whole paper is how I find things. So here's some things we can think about. I want to do a grid, and I like to use the isometric grid a lot. So I'm going to turn that grid on. I select this grid. So this is how you turn on the grid. Select the one you want, turn on the grid. And then I like to, when I first start, have fixed, because I like them to be on the points. And actually, let me show you the difference so that you can see how these 3 different options work. Off means they're off. Snap means something different than fix, and I'll show you what I mean. So I'm going to turn off auto labeling. I do not like it, so I'm going to hit OK. So right now, I didn't turn on snap or fix. So if I started just putting a point on here, I could put my point anywhere because I don't have any control over where it lands. So if I'm trying to be precise and make, if you can see the isometric grid, I could actually see some cubes in here. If I wanted to be precise, if I don't have it on, it's very hard to land precisely on a vertex, right? Or a intersection point. So if I go back and I turn on snap, snap will snap kind of, well, it's not going to do it. It doesn't do it as well in the isometric grid, but if you were on a coordinate grid with like the little mini grids, it snaps to an intersection. In the isometric, the fixed works. Oh, I forgot to, sorry, you have to remember to hit OK. That's why it wasn't working. So you'll notice, see how as I get close to something, it snaps onto it so that I know that I'm definitely on that intersection. And fixed is just even more precise. So if I turn fixed on, that's even a more precise than snap. And fixed means when I move the point, I can only move it from intersection to, it won't even let me stop halfway. It only goes from intersection to intersection. So that's sort of the difference between them. Snap lets you snap if you're close to an intersection, but you could also land it somewhere not on it. But fixed forces you to only be able to move between intersections. So it sort of depends what you're looking to do. And in this particular case, I'm trying to construct something very precise, and then I might turn it off later, but right now I want to construct it so that it's precise. So let's say I want to, here's the things I've been playing around with. I wanted something that would grow. So let's say we're talking about prisms, and I want students to see the volume and the area type of thing. So I want to construct the smallest one right now, which is a cube. So I'm going to get, so this is what I've been playing with. I'm going to use 2 points. And I want to have something that moves these up and moves them along this line here. So that's sort of a control with a slider, or in my case, I've been playing around with a vector. So this is just something I've been playing with today that I discovered is pretty cool. So I'm going to get the vector, and I'm going to make, and I actually want to change the color so that, so if you're in the geometry, this little right arrow, depending on where you are, if you're way over here, it turns up on the, there we go. If I'm over too far, all right, sorry. If I'm over too far, I just wanted to show you that it switches sides there. So it's on this side. So depending on where you are, that arrow kind of switches sides. So I'm over here. And this is where all of your tools, your other tools are. So you have tools at the bottom, plus you have things like tools you can do once you put something in the screen. So I want to make a vector, and I want to change the color so that my vectors have different colors. So I'm going to make one vector that's going to be my, it's not really my horizontal, but I'm calling it my horizontal shift. And then I'm going to make another vector that is my vertical shift. So these are controlling my direction of my 3D object once I make it. Let's make this a little bit bigger. So this is a vector, and I can move it, and notice it doesn't stay on the line because I haven't locked it, and I don't want to lock it. I'll show you why. But I want to now translate. I'm going to use some construction. So this is what I was playing around with today, because I want to create a 3D object that actually grows in size as I move it around, so that I can explore different parts of it and different volumes and those types of things. So I want to take these 2 initial start points, and I'm going to select them. So in geometry, I select what I want to do something to, and now I go to my toolbox over here, and what do I want to do? I want to translate them. So notice under construct are my transformation menu, and I'm going to go by vector. Now I could do it by coordinates, but I want the vector to basically control the movement. So I'm going to say, yes, let's do vector. And notice up here, I get a direction that sort of helps me. It's a hint on what I should do. It says, well, tell me what vector you want. Well, let's do our vertical shift first. When I click the vector, watch what happens. I get 2 new points that are the translation of this, right? And I'm going to actually change their color to be blue. All right, so now, so that is going to, and so watch what happens, because these 2 points are controlled by the vector, they move with the vector. So I have basically created my one direction move. So now I need to create the other one. So now I want the shape to also grow horizontally, if we're thinking about it that way. And I want all of these to be translated. So I'm selecting all the things I want to translate, and I'm going back to my options over here. I'm going to my constructions, and I want to do another translation by vector, but this time I'm using the orange vector, my horizontal shift. So now I have 4 new points, just going to make them blue, that are controlled. So watch again. They're controlled by the orange. There we go. What I want to do now is actually make my 3D object. So I have all the vertices that I want. So I'm going to use my Polygon tool. And what I like here is I can change the colors. And this is where you can think about nets and what are the shapes that make up a 3D object and what's the area, what's the surface area. We can kind of build that from our shapes here. So I'm going to do the bases first, and I'm going to let them be, let's make them blue. So I'm going to use my Polygon tool, and I'm going to outline the base. So right now, what's that base? It's a rectangle, and the top of my shape is, or my second base is also a rectangle. So, you know, when they're thinking about the formula, there are 2 identical bases. And how do I know they're identical? Well, I know that I translate them, but I could also just physically show it. If I use my translation and go down to the beginning, they land right on top of each other. So I know that those are congruent bases. So I have 2 bases that are in this particular prism a rectangle. And so now let's connect the sides, but I'm going to change the color. So this is the nice thing, is you can really be creative in your colors. So let's make this side red. And again, I'm using my Polygon. So now I'm going to connect the 4 vertices here, and I have one of my sides, and I have another side directly across from it, so that looks like it's exactly the same. So I'm going to make that one also purple. So now I have 2 sides that are the same. And again, how do I know they're the same? Well, I can talk about how they were constructed, but I can also put them on top of each other to show that they are congruent to each other. And then I have 2 other sides. So basically, as we're doing this, we're really thinking about surface area. If I was going to wrap this box in the surface of it, I have these 2 rectangles I need the area of, these 2 other sides I need the area, and then this final 2 sides. So this is where the formulas are coming from. So it's a really nice kind of building of these 3D objects. So let's change the color one more time. Let's make it orange. And now I'm going to get my Polygon tool, and I'm going to do the one in the back first. You'll notice as the colors overlap, you can see I can highlight them. That's in the back, but it's kind of overlapping on 2 of them. And let's do one more side. Whoops. Sorry. There we go. I'm trying to follow the vertices. There we go. All right, so now I have my shapes, and maybe I want to do different color. But what I like about this now is it's controlled by this vector over here. And so I can basically build lots of different rectangular prisms. So this one is a cube, and we can think about the area. I could even measure the width. Oops. Okay, so for those of you not, I am measuring by selecting the object I want. So I want this height measured. And I want this length measured. Right, so I've measured. And in Classpad, you automatically get a label. Anytime you measure something, you get an automatic angle name or an automatic slide. If you don't like them, so I'm going to notice how these are selected. And let me do that again. I selected the actual measurements. And by doing that, my only options are this visible here. And I can, here's where I can turn off the label, which I tend to like to do. And this right here is called a sticky. And that always happens when you have a measurement, because this allows you to do a calculation. So for example, let's say I want to measure the volume of this using the current measures or make it a dynamic measure. I could go to, no, that's not what I want. Sorry. I think I've got it. There we go. If I go to measurement, down at the bottom is an expression. So that's basically where you can do a dynamic calculation. And so notice the minute I did that, it puts these little plus signs next to the measures that I have, because this is going to make it dynamic. So what do I know the volume is of a prism? I know that it's this measure, and I'm going to use my template that's popped up, times this measure. So all I'm doing is putting the plus sign, and it's putting in that dynamic measurement. And then when I hit execute or enter, it's going to enter the volume here. So this current version of the object has a volume of 8. So what happens if I double the height? So I'm going to make the height 4. Well, what happened to the volume of it? It has done what? It went from 8 to 16. So doubling the height doubled my volume. Well, what if I double the height and double the width? What happens now? I'm at the original. So you can really start talking about those ratios. You can pull up a calculator, but now I have this object that I can now change in different ways. I can make it bigger, taller. I probably should have added another dimension. And notice as I change the vector, I'm also, hopefully not, I can also change the perspective of the object and have different ones, those types of things. So this was just one way that I can create a 3D object that sort of can move and be changed, and I can measure things and I can compare the measurements because I created an isometric grid. Now maybe I don't want to have the grid on anymore, and so here you can make that choice. Do you still want things to be fixed? Do you want it to always, because that does kind of control how it moves a little bit. So if I turn that off, and if I turn off, well, actually, let me show you what happens. If I turn off fix, watch what happens. Now I can actually move this thing. Oh, sorry, I forgot to hit OK. I do that a lot, just so you know. But now notice I can actually, I have a lot more freedom if I don't have fixed on. So I use fixed often to create my object initially and then turn it off so that I can create and move a little more freely about the screen. So before I move on, I just want to make sure there's no questions that I need to answer or you need me to show something again. I am going to ask for your help in a little bit because I've been playing around with this all day and the last couple of days, and I've just been discovering, like this whole vector thing I just figured out today. I was doing it different ways, and I'm going to show you a different way to do things as well, but it was just something I discovered. So are there any questions, Amy?
No, we didn't have any questions.
Okay. And what, I don't even know what time it is. Do you know what time it is?
Yeah, it's almost 6:10.
I know I run on and on and on and on. I'm going to come back to this and show you some more constructions, but basically it's kind of whatever you decide to do. So to make 3D, you're either going to probably want to use the dot grid or the isometric grid, and I tend to use the isometric grid a lot because I can make more interesting shapes with the dot grid. You're a little more confined, I think, but I'm going to do one with the dot grid in just a minute. But before I do that, I wanted to show you another way where these 3D objects that you can create come into play. Because another type of question students are asked is the elevation type questions, where they're given a solid, an image of a solid, and they're asked to do the top view, the side view, and the front view. I don't know why my front didn't come in. So this is something I constructed this again on, I think I did isometric. So let's turn that. Yes, I did do an isometric grid. So just to show you, I made this on the isometric grid initially myself, and then turned off the grid so that the students aren't seeing the grid, because the grid kind of distorts things. And then this little side top thing, that's just a text box that I added in. So if I don't know what happened to my front one, but all I did was hit text and type in that. And so now this is the front view that I want them to do. So students can then use you can provide them. So this is an activity. So basically it says use the geometry stickies to draw the top, front, and side views of the given solid. So they also can be using these grids to do things. So a dot grid makes more sense for what the students have to do because these are all cubes. So they're not making a different perspective. So if I'm looking at the top view, what's the student going to see? So hopefully they're going to maybe use their polygon tool, or they could use the segment tool. So it's 1, 2, 3, 4. So it's 4 across. 1, 2, 3, 4. And then it's down. I'm just, and notice I don't have snap on. So as I should have, as a teacher, turned snap on already. Which I don't think I did. So this might be the, and I could do all the segments and stuff, but this is another way that you can create like these 3D objects, and then they can be looking at the elevation and the perspectives from the top, the side, the front. This is definitely something that I know is on assessments with geometry. You know, it's kind of that perspective thing. And I would recommend, I did not do it. Oh, I did do it. Snap. I would probably do fixed, but snap works. So this is an example, and here's another one that I did, and I was trying to get a curve in here. And so when you're trying to do something like a cylinder, it's a little harder, but when you're trying to do a cylinder, I use an ellipse tool, which I'm going to go back and show you. But again, I did this initially on the isometric grid. And I use snap points, and then I locked it, I think, yes. So notice I can't move any of these points, and that's because I selected the whole object. I did this, I selected the whole object, except you can't have the words. And I went to lock and locked them so that the students couldn't move them. So that's just something, another exploration. So that's the third one in the handout that I gave you, just so that you had something to look at. But I just created those using, you know, the isometric grid to help me. So I want to open another geometry sticky in whatever time I have left and just show you some ideas for the cylinders. For me are the hardest, but because Classpad doesn't yet have a way to construct the inside of conics. So in a polygon tool, you get the colored inside, but in a circle tool, you don't have the inside colored, the area colored, or in any of the conic tools. And so it's a little harder to visualize, but let's say I wanted to do a circle or something that looked like a sphere. Oh, sorry, let me turn off auto labeling. Let's say I want the circle tool and I want to simulate a 3D sphere. It's much hard. This is probably the hardest tool. And so what I have been doing is using the ellipse tool. So down here in my bottom tools, here's Polygon, but if you click that, there's lots of options, and you notice there's 2 ways to do an ellipse. And I have found this one right here, which is by the axis, is the best. So I've been trying to simulate a sphere, and I'm going to make this dotted. Dotted is another way to give the illusion of 3D. So if I choose this tool, and here's my center, and I'm going to go out to the side of my circle and then connect. Now again, it's just an illusion, but that's an illusion of a sphere. So that's one way if you're trying to, you know, work with students, and because now you could actually do the perpendicular here, so you could do the height, the radius of the sphere by doing a segment. It's actually on the line. So you could do a segment that connects this to this. And now I'm going to hide. So this is where the hide show features of any geometry tool, but of Classpad. I don't want to see this line anymore. So if I select it and go to my little arrow to the right, I can just make it not visible. So it's gone now. Or I could also make a hide show button. So notice it's created, and I could hit group, and that creates a hide show button. that will bring it back when I want to. So kind of your decision how you do it. But this is sort of an illusion of a 3D sphere. So that's just some suggestions for how to do that. And let's say you want to do a cylinder, or actually we haven't looked at any pyramids or things like that. So let me show you some ideas on how to simulate those. So I'm going to turn on the isometric grid. So again, 3 dots, turn on the grid you want, turn it on, turn off auto labeling. I'm going to hit fixed points just to at least create. And now I'm going to make a pyramid with a triangular base. So I'm going to use the Polygon tool. Now, right now, it's definitely equilateral, which is fine for what my purpose is, because I'm going to turn fixed off in a minute. But this is just a way to help me construct it. I'm going to change the colors. So properties, because I want my sides to be different. So let's make the vertex up there. So there's one side of my triangular pyramid. So let's make a different color. So all I'm doing is using the Polygon tool and making sure I connect all vertices to create that side again. There's my last one, and I'm going to do darker color for my one that's hidden here in the back. So there's my 3 sides, and now I've constructed it. So now I'm going to turn off the grid. And I'm also going to turn off fixed. And the reason I'm doing that is because fixed will force anything I try to put on this shape to even if it's hidden, to one of these vertices, one of these intersection points, and I don't want that anymore. I just needed it when I was constructing. So now I'm going to turn it off. And now I have this 3D shape that I can then manipulate and move if I wanted to, change it and have a different perspective. And let's say I wanted to add in the slant height. So I would want to construct, say, the midpoint of one of the sides, and then use my segment tool and maybe let's make it red and dotted. And now from the vertex to this midpoint, there is my slant height. So we could now discuss, this side right here has this slant height, and measure it and find the area of this side. And now we have to do the same thing. So you could really kind of add and build on all those formulas just from your initial construction and kind of add things on. So even though technically there's no 3D on here, those isometric and the dot grids really make it really easy to construct 3D objects and really use them to help students understand the formulas. So I am finished unless there are questions. So this was just to kind of introduce you to the things you could do and things you can create. I'm still exploring. I was excited to figure out the vector thing today and how to make things grow and shrink. So I'm going to explore that more and maybe create some more activities with that. But are there any questions, Amy?
No, we haven't had any questions.
Okay, you guys are easy. So if there's no questions, I'm finishing a little early, but I know it's someone says question. I'd be happy to show you anything because I know I go really fast often when I'm doing things, and some of you are not as familiar with this as I am. So if you want to see how I did something again, I'm happy to do that. Just let me know. But everything I did today was in the geometry sticky. So just the click anywhere, and it's the one that has the circle and the triangle. And it's working with the grids, and there's a lot of things you can do with transformations.
Karen, will you reshare that PDF that you shared at the beginning of the webinar?
Absolutely. Absolutely. And it'll also be in a follow-up email.
Yes.
Let me make sure I'm sharing the right one. All right, everyone
Yes,
get it?
Yes, it's there.
And actually, let me just talk about, since I have some extra time, let me just go back to the landing page for the software, if it'll let me go back to it. Okay, so here's the landing page. Again, I really highly recommend you create an account because, for example, the 3 activities that you have links to, when you open them up, they're not in anybody's account. You're just playing with it, right? And if you want to save it and have it forever, if you have your account logged in, so I have my account, I'm logged in technically right now, so I see this little icon pops up and it's called duplicate. So if you have an account, that icon will open up whenever you find an activity. It'll open up, and if you like the activity, you hit the duplicate button, and I'm just going to do that. So now I'll have duplicate. And what it does, it's basically creating a copy of the original into your account. And so now you have it. You can add to it. You can put questions in it. You can take things out, all those types of things. So now, if you notice the difference, it now has the save cloud icon, because now I duplicated it and now it's my copy. I have a copy of my own. So the original never is changed. Whoever created the original never changes it, but now it's in my papers. And over here in my account, I'm just going to go to it and scare everybody. This is where all my papers, if you have an account, your papers are being saved. Everything you do is being saved. And when you go into it, and I have a lot of papers, so just don't panic. You'll see here's the paper that I just duplicated. It's right here. This is the paper that I just noticed. I have 2 of them, because actually I probably have 3 of them because I have done it more than once. So here's the original. The original, I know it's the original because it has this little shared icon, meaning I've shared it publicly, but here's the copy of it that I just duplicated. So basically I duplicated another one that I could change. It's not the shared one. And notice, just real quick, I have folders. I need to do some organization, but you can organize your papers by content or however makes sense to you. You can just create folders really easily. So creating an account's really nice, especially if you're going to try and work with students. I teach online, and so I make a lot of activities that I share with my students. So I just send them the URL like I've done with you, and then they work on it. They make their own copy, send me back their copy with their work on it. So it's a really nice feature. You can do a lot online because it's visual, and students can work on their own, or they can work with you online, those types of things. And back to this, there are hundreds of activities that are already available. So if you have an account, you can access those. And teachers who make things and share them publicly, it goes into the library. And so those are all available for you to look at. And on the website, you can kind of see a snippet of some of those activities. I just went to activities, and you'll see that we've kind of categorized them by content level. And so if we click in geometry, here's a ton of geometry activities. And these are just activities. If you click them, they open up. You can play in them. If you want to save them, you duplicate them into your own account. So hopefully that was way more than the question asked for. So sorry about that. And so I'm going to just kind of end with letting Amy update us on things.
Well, thank you very much, Karen, for your time and going through all that stuff. It's definitely fun to see how you can kind of manipulate 3D images, even though we don't have that 3D feature.
Yes,
that drawing,
yes.
Let's say yes. Drawing tool. Yeah.
It's coming.
Yeah, exactly. Yet. So next week, we are going to actually take a look at trying to do some 3D shapes with area and volume as well on one of our graphing calculators. So it's the FXCG 500. That is our CAS model. So it does have some of those added features. So that's the webinar for next week. And then we meet every Thursday evening at the same time, 6:30 p.m. Eastern, to do additional webinars. And so starting in August, Karen and I are going to be alternating, talking about how you can plan and organize your technology, how you can incorporate technology into your classroom, even though you don't have necessarily time to teach it, really focusing on back to school sessions that we think would be beneficial for teachers as everyone's kind of figuring out how they're going back to school, as well as taking a look at some of our hardware. So you can go to the Classpad.net webinar link or the Casio Education webinar link there to sign up for any of those that are there, and to also see additional webinars that are coming up for the rest of August and September. Additionally, we are adding more webinars to our series. We are doing a series on equity in education with a bunch of guest speakers. So we have 2 that are scheduled right now for August 4th and August 12th. They are at different times right now. And so those will all kind of be at different times. So you'll just have to make sure you're watching out for that.
And this is in partnership with Todos and
yes.
Benjamin Banneker Association. So
with
those
the
are where the
BBA group.
speakers are coming from. And so you can see who they are on our website.
Right, on the registration links.
Yeah.
Yes, and so you can find the registration links as well on the Casio Education webinar page. And that just about wraps it up. If you guys have any additional questions, feel free to throw them in the chat panel. Otherwise, thank you for attending. If you need a certificate of attendance, just to kind of get credit for this hour webinar, please email classpad.net@gmail.com, and then follow us on social media for other webinars and other activities that we'll share. And you can find the recorded webinars and other videos on our YouTube channel as well. Thank you guys for your time.
Thank you very much. I appreciate the interactions and questions. Have a great night.